Please find a half sheet of paper, write the quadratic formula on it with your name, and hand it in as a pop quiz. We're going to continue with complex numbers today, day 2 of section 8. Yesterday we talked about how we can simplify imaginary units, and then we added, subtracted, and multiplied, and today we're going to divide. So just a very quick reminder about multiplication. I want you to consider the product that's up there, 2 plus 5i minus, and 2 times, I'll start that again, sorry. 2 plus 5i times 2 minus 5i. If I FOIL, 2 times 2 is 4, 2 times negative 5i is a negative 10i. 5i times 2 is a positive 10i, and 5i times negative 5i is a negative 25i squared, which I'll immediately fix. It's plus 25. Combining the reals, 4 plus 25 is 29. Combining the imaginaries, negative 10i plus 10i cancels. Consider what just happened here. We had two complex numbers, 2 plus 5i, 2 minus 5i, and when we multiplied, our answer became exceptionally real. 29 is a very real number. It's what we're used to. All the imaginaries disappeared. Why did that happen? Why did the middle terms, the O and the I in FOIL, cancel? And the reason it seems as though they're canceling is because this sign is positive and that sign's negative. The complex numbers themselves are the same. We have a 2 and a 5i, but one's positive and one's negative, and so they cancel. Test your theory on negative 1 plus 2i and negative 1 minus 2i. Pause the video and FOIL it. See if your answer becomes real. You end up with 5, which is very real. 5 is very much so a real number. And so as long as the complex numbers are the same, except their signs in the middle, in front of the I term, if the I term has an opposite sign, your product is real. That's called a conjugate. A conjugate means the complex numbers are the same, but the imaginary part of them has an opposite sign. When you multiply two complex conjugates together, the product, the result, is always real. So we're going to talk about conjugates first. In order to list the conjugate, all you do is change the sign in front of I. So in number 1, 2 plus 3i, its conjugate is 2 minus 3i. You change the sign in front of I. Number 2, the conjugate of negative 4 plus 2i is negative 4 minus 2i. Number 3, the conjugate of 5 minus I is 5 plus I. Again, we're changing the sign in front of I. Number 4 might seem tricky at first, but the conjugate of 7i is just negative 7i. Change the sign in front of I. And number 5, negative 3 minus 3i is negative 3 plus 3i. Change the sign in front of I. Conjugates are the same except for the sign in front of the I term. A fraction is not considered simplified if the denominator contains I. This is important. You cannot have an I in the bottom of a fraction. In order to fix that, if there are any imaginary numbers or terms in the bottom of a fraction, we're going to multiply the top and the bottom by the conjugate of the bottom. And that'll help us clear the i's in the bottom. Pause the video if you need to copy this down. So if you take a look at the first example, the issue here they want us to divide is that there is an I in the bottom. So take a look at the bottom of this fraction. It is 3i. The conjugate of 3i is negative 3i. So I'm going to multiply top and bottom by a negative 3i. You'll notice I take care of the bottom first because I make sure that the i's go away. 3i times negative 3i is a negative 9i squared, which is really 9. On the top, I have to distribute. It's like I'm taking this negative 3i times everybody. Negative 3i times 12i is a negative 36i squared. And negative 3i times 9 is a negative 27i. Now I'm going to play two tricks in the next step. First of all, I'm going to change this negative 36i squared to a positive 36. And then I'm going to rewrite them, make this 36 minus 27i, as two separate fractions. We first did that in this course when it came to quadratic formula. We make this 36 over 9 minus 27i over 9, which reduces to 4 minus 3i. Gets a little bit more complicated when the denominator is an actual complex number with a real part and an imaginary part. The denominator here is -2 plus I, so its conjugate is -2 minus I. I'm going to multiply top and bottom by the conjugate, which is -2 minus I. I'm going to focus on the bottom first. I'm foiling. -2 times -2 is 4. -2 times -I is a positive 2I. I times -2 is a -2I. And I times a -I is a -I squared, which I want to fix right away. -I squared is really a +1. So the denominator here, my real parts, 4 plus 1 is 5. 2I minus 2I cancels. If you have an I in the denominator after you've tried to FOIL, then you've done something wrong. It should cancel. That's the whole point of a conjugate. We have to FOIL the top. 4 times -2 is -8. 4 times -I is a -4I. 3I times -2 is a -6I. And 3I times a -I is a -3I squared, which I'm going to fix immediately to a +3. Reals first, -8 plus 3 is -5. -4I minus 6I is a -10I. I'm going to uncommon denominator. I've got -5 over 5 minus 10I over 5, which all reduces to a -1 minus 2I. Number 3, I see an I in the denominator. The denominator here is 3 plus 4I, whose conjugate is 3 minus 4I. So I'm going to multiply top and bottom by 3 minus 4I. Bottoms first. 3 times 3 is 9. 3 times -4I is a -12I. 4I times 3 is a positive 12I. And 4I times a -4I is a -16I squared, which I'm immediately going to fix. That's +16. So in the denominator, 9 plus 16 is 25. -12I plus 12I goes away. Cancels. All right, foiling the top. 5 times 3 is 15. 5 times -4I is -20I. -2I times 3 is a -6I. And -2I times -4I is a positive 8I squared, which I'll fix is a -8. Reals first. 15 minus 8 is 7. -20I minus 6I is -26I. If I uncommon denominator, I get 7 over 25 minus 26 over 25I. And I can't reduce any of them, so they just stay like that. That's a complex number whose real part is 7 over 25 and whose imaginary part is -26 over 25. Pause the video to complete the U-triads. Today we learned that a fraction is not simplified if there is an I in the denominator. We were introduced to A plus BI and A minus BI, which are called conjugates. Both the numerator and denominator are multiplied by the conjugates to simplify fractions whose denominators contain I.